Have you ever been driving during a really heavy downpour and you see the road ahead start to look, well, more like a river? It's a pretty common and honestly kind of scary experience. But what if it's also a warning sign? A sign that the hidden systems right under our feet are struggling to keep up with a world that's changing faster than they are. Okay, let's get into it. So, we're going to kick things off by looking at this problem we can all relate to. Why our roads seem to be flooding so much more often when big storms hit. It really is the big question, right? We build these incredible, massive road networks, but it feels like they're getting more and more vulnerable every single year. So, what is actually going on? And here it is. This is the heart of the issue. All those pipes and drains and ponds that are designed to handle rainwater, they were all built based on weather patterns from the past. But as our climate changes, the storms we're seeing are just bigger and meaner, and they're completely overwhelming this older infrastructure. We're basically trying to fight future weather with yesterday's tools. Now, you might be thinking, all right, simple, just build bigger drains. But, it's not nearly that easy. Trying to predict exactly how much wetter our future is going to be is an incredibly complicated puzzle. Let's break down why that is. So, scientists are up against 4 huge challenges here. First off, the actual physics of how rain forms and falls is just wildly complex. Second, we don't have a ton of great data on those really short, intense downpours, the kind that cause flash floods in minutes. Third, a lot of the big climate models, they're just not detailed enough to predict rainfall on, say, one specific highway. And finally, every projection about the future climate comes with a huge range of uncertainty. For engineers trying to plan ahead, it's a massive headache. So to cut through all that uncertainty, researchers have come up with a totally new way of looking at the problem. It's a real game changer in how we think about forecasting and risk. Okay, I know this slide looks pretty intense, but don't worry, you don't need to memorize it. You can really boil it all down to a simple 4-step battle plan. That top box, step 1, is all about figuring out the hazard, modeling storms from the past and the future. The box below it, step 2, is about understanding how vulnerable the drainage system is. Then, step 3, on the right, is where they combine all that to figure out the real-world impact. And finally, step 4 at the bottom is about using all that info to make smarter decisions. It's a system for turning "we don't know" into "here's a plan." Now, the real hero of this whole new approach is something called a probabilistic model. It's a fancy term, but the idea is simple. Instead of trying to make one single best guess about what's going to happen, this method runs thousands and thousands of different simulations. It maps out a whole landscape of what could happen, which is way more useful. Let me give you an analogy. The old way of doing things is like trying to predict the exact final score of a football game before it starts. It's almost impossible. The new way, the probabilistic way, is like running a computer simulation of that game 10,000 times. You don't get one correct score, but you get a fantastic picture of all the most likely outcomes. You understand the risk so much better. All right, so this all sounds great in theory, right? But does it actually work in the real world? Well, let's dive into a case study where scientists used this exact method to put the road drains in Ireland to the test. So, back in 2015, Ireland's Transportation Authority did something pretty smart. They proactively beefed up their drainage design standards by 20%, specifically to get ready for climate change. It was a really forward-thinking move. But the big question researchers had was it enough? Did they get it right? Okay, so first things first, they had to create the threat. They used a bunch of different climate models to generate thousands of virtual superstorms for what the world might look like at the end of the century. On this chart, the solid lines show you what historical storms looked like. The dashed lines, that's the future. You can see right away those future storms are projected to be way, way more intense. Next up, they needed something to throw those storms at, so they built what's called a digital twin, which is basically a perfect, super detailed computer replica of a standard Irish road drainage system. As you can see here, the model has everything: the drains, the pipes, the manholes, the ponds. This lets them run all kinds of tests on the computer that you could never do in real life. And then came the fun part. They took those thousands of virtual future storms and just unleashed them on the virtual drainage system. They ran simulation after simulation after simulation just to see where and when the system would break under the stress of a future climate. So, after all that work, all those simulations, what did they find? Well, let's get to the results, because they were, to put it mildly, quite sobering. First, let's just talk about the sheer volume of water.
Under a high emissions scenario, the models predicted that the most intense storms in the year 2100 could dump up to 55% more rain into the drains compared to what they were built for. That's a massive, massive increase for any system to try and handle.
Okay, now here's a really crucial piece of context. The official Irish design standard says very clearly that the pipe network should be able to handle a common 5-year storm without any flooding. Zero. The system is literally designed for zero failure under those conditions.
And this chart right here, this is the punchline. Historically, the chance of flooding during that standard 5-year storm was, just like the design said, 0%. But in the future, the models show a 4.4% chance of failure even in a medium emissions future, and that risk nearly doubles to 8.7% in a high emissions future. A system that was designed to never fail now has a real, significant risk of doing just that. So the bottom line is this. Even though Ireland's 20% upgrade was a great step in the right direction, this much more detailed, probabilistic analysis shows it probably isn't enough to handle what's actually coming. It proves that our future planning has to be guided by this kind of hardcore data. And this leaves us with a pretty big question to think about. This study, it just focused on one type of infrastructure in one country. But it really makes you wonder, if the drains under our roads are unprepared for the climate of the future, what other critical, hidden systems in our cities, our power grids, our food supplies, what else are we forgetting?